Hello, in this video I'm going to show how to do fixed effects in STATA, but before that let's look into the theoretical aspect of fixed effects model. Fixed effects is our third model that we are looking at in panel data modeling, and fixed effects is also called the within estimator because it looks into the information within individual over the years. It has other names like the covariance model or the least square dummy variable. So you create a dummy variable for all the unit that you observe, and that is why it's called the least square dummy variable. The main assumption of fixed effects is that the time constant characteristics of an individual or a company that you want to observe are perfectly collinear with the individual. Alright? So the rationale is that we have the correlation between the error term that is specific, the error term, the UI that we have been looking into, which is correlated with the explanatory variable. That is the main assumption about the fixed effects. So the UI is correlated with the error term. So fixed effects is designed to study changes, the course of changes within a person or a company. And so how does fixed effect remove the UI that we are concerned about? Fixed effects does the transformation by taking averages. So you take all the values of a variable for the years and divide by the total number of years. Then when you take that average, then you subtract the average from the individual's, the variable itself. So this is how the transformation looks like. So we take the averages of all the variables. And then by subtracting equation 6 from 3, we remove UI. Alright, so UI is constant, so we take average the same value, then we remove UI. Unlike in the first difference where you subtract the previous value from the current value, we have the averages being subtracted from the current value in fixed effect modeling. The fixed effects also assume that the individual characteristics are constant, are assumed to be unique to only the individual and do not correlate with all other individuals. Let's look into the advantages of using fixed effects model. Fixed effects model will control for individual heterogeneity, just like in the first differencing, the same approach. And also fixed effects is always consistent when the correlation between the fixed effects, UI, and the explanatory variable is not equal to 0. So fixed effects is always consistent under the alternative hypothesis. But fixed effects has some limitations. The obvious one is that it cannot estimate the coefficients of a variable that is constant over time. So if you have a categorical, a binary variable that does not change over time, fixed effects will eliminate that in the transformation, as we have seen. And fixed effects is also less efficient under the null hypothesis. So if the correlation between UI and the explanatory variable is equal to 0, then fixed effects is less efficient, because in this case it ignores the variation across the unit. Fixed effect looks into only variation within the unit. So let's see how fixed effects is done using STATA. So you open STATA always remember to open your do file as I showed in the previous videos. Open your do file first, then you open your data from wherever you store it. So I go back to the data set we have been using, which I opened already. So, and then we run the fixed effect model. So I run my fixed effects model, and then we see what we get. All right. So here we have the fixed effects model. If I copy the equation again, just to remind us about what we did last time about the random effect model, I copy this equation and I just change this to RE, meaning random effect, so that we can see the differences. So as I mentioned, random effects is able to see random effect, all the variables are estimated. Fixed effects, as we mentioned, it cannot take into account time constant variables. It will eliminate them. That is what we have just seen here. He has taken out this variable called the female and black and education. He has eliminated them. So that is a problem we have mentioned in the disadvantages aspect. But now let's explain the result. This number of observations is the same as before, and we have observation per group, all the same. And then here now we have the within R square being highlighted, meaning that we have estimated the fixed effects, or also known as within regression. So now the error term, the R square, this is what we are going to report in our paper or in our result, or whatever we are doing. And here we have the F statistics showing that our model is correctly specified. We haven't left out important indicators. And now here we see that the correlation between the UI and the explanatory variable is not equal to 0, because that's the main assumption. So here we have a correlation being very high. All right. And now we go down to this result. In the random effect model, we have 0.2626 for the UI, and for the fixed the remaining error time we have 0.1519, and then the proportion of variance due to UI is 0.749. All right, now let's compare that with that of this. So we see that the UI aspect has now increased, and then the remaining error time remain the same as what we have here. So why this one has it increased? And then the proportion, of course, will also increase. The UI has increased because we could not estimate femme, the female, black, and the education. So this component that could not be estimated. So this UI now control for those we could not estimate it, meaning that if we don't observe them and they are constant over time, they are included in this value. So, and of course, including the previous value of UI in, as we saw in the random effects regression. But for the, as I mentioned, this value, the sigma E is the same as in the random effect estimate. And the rho has increased, and this is how we compute for the rho. It increased because these three variables could not be estimated. Therefore, they are controlled for in this UI. And we take the variance of UI over the total variance. That's what it simply means. This is the standard deviation, so when we square it, it gives us the variance. And fixed effect also report another test is below. Here it is. And what does it mean? It shows that we have some significant differences between some of the units. At least some of the units have some significant differences. So company A and company B, for example, are different. So that is what it means here. So therefore we need to look into these differences. So basically this is what the fixed effect regression will give you. The result looks like, and this is how we explain the error terms regarding UI, VIT in our case, and all the values we need to explain. Thank you for watching, and in the next video we'll look into how do we choose between fixed effects and random effect, which one is appropriate.